Welcome to the GSSI Research Doesn't Stop webinar series. I'm Alessandro Palma, GSSI faculty. Sorry, may you please mute your microphone? I think this is our last webinar of the season, and it's great pleasure for me today to present Valerio Leone Sciabolazza in this session. Valerio is an assistant professor at the Department of Economics and Management at the University of Naples, Parthenope, and he was previously a postdoc associate at the Swedish Institute for Social Studies and the University of Florida. Valerio's core research interests lie on spatial econometrics, econometrics of networks, and the new science of networks. He published on network diffusion process, innovation externalities, spillover effects of conflicts on economic growth and migration behavior. And he also analyzed the role of political patronage networks in determining legislator activities. And he's also consultant for the World Bank and the International Fund for Agriculture and Development. And very recently, Valerio joined the editorial board of the Journal of Economic Geography as an associate editor. So we are very glad, Valerio, to host here today. And Valerio is going to present a paper titled Network-Driven Positive Externalities in Clean Energy Technology Production, the Case of Energy Efficiency in the EU Residential Sector. Let me summarize once again the rules of the game. The webinar will take about 2 hours, 1 hour for presentation and maximum 1 hour for a discussion. So we have a long time for discussion. As the chair for this session, I'm in charge to collect questions and moderate the discussion on Zoom, while Chiara Burlina will collect questions for those who are following Valerio on our official YouTube channel. Quick questions, technical questions, and clarifications are allowed, but please consider that we are going to have an extensive discussion after Valerio's presentation. And an important information, this webinar is going to be recorded, but if you prefer, those of you who prefer not to be recorded, please leave Zoom and follow the session on YouTube. And last but not least, please mute your microphone and let Valerio have the spot presentation. And I think that's all. So Valerio, the floor is yours.
All right. Thank you, Alessandro, for this kind presentation. So first things first, I want to share my screen so that you can all see my slides. Okay, so I think I'll hide this. And so can you see my slides?
Yes, we see.
Okay, perfect. So thank you everybody for having me here today. Today I will be presenting a joint work with Valeria Costantini from the University of Roma Tre and Elena Paglialunga from the University of Urbino. And the aim of the work that I'm going to present is to shed new light on the production of clean energy technology by analyzing the role of external knowledge spillovers. And in particular, we focus on the extent to which countries, by interacting with each other, have the opportunity to be exposed to new ideas and productive opportunities, and use these ideas and opportunities in their innovation production system, so to increase the production of clean energy technology. So let's go to the main motivations of the work, why we study this topic. Well, basically, understanding the determinants of the creation of clean energy technology is a matter of both practical and theoretical importance. And the reason is that from a normative perspective, this study may help us to design more efficient policies to transform the sustainable energy transition into a development opportunity. And at the same time, from a positive perspective, this may help us to explain the drivers of the development of new green technologies. Therefore, it is not surprising that a large literature has been already devoted to measuring and explaining the innovation performance of countries in the creation of green technologies. This large array of work can be roughly grouped in two streams of research. The former one is that investigating bottom-up actions, that is the capacity of agents, firms, regions, and so on and so forth, to create new technologies favored by their pre-existing knowledge base. Then we have the second stream of research that is related to the investigation of top-down coordination in policy mix design that may facilitate the development and deployment of new technological trajectories. Now, said that, we also have that the literature has always recognized that another key factor in determining the diffusion of green technologies and innovation externality, the diffusion of green technologies are innovation externalities that flows across countries. And this is exactly what we want to study in our work. So our main research question is to understand the degree to which cross-country innovation spillovers matter in determining the national creation of new green technologies. Of course, we are not the first who aimed at this question. The first evidence, the first empirical evidence about this, this correlation between measures of innovation spillover and the national knowledge creation was provided by Bottazzi and Peri in their seminal work in 2007, followed by Mancusi in 2008. And in these works, they show that the international knowledge stock that is common to our countries basically represent an opportunity for a country to acquire new knowledge and use this knowledge to improve its innovation performance. Then more recently, a new piece was added to this story by research from spatial econometrics. In these works, they show that countries actually benefit in different ways from spillover effects. And this depends on their geographical position. So basically here, the intuition is that if you are located close to a country that is very innovative, then you're more likely to be exposed to new ideas. And you can use these ideas to improve your innovation performance. Well, more recently, a new hypothesis emerged in the literature. This hypothesis posits that a country or an industry might be able to capture innovation and productive opportunities also by trading with its partners. This is, for instance, the case of the work by Ho and his colleagues in 2018. They show that the absorptive capacity of external knowledge spillovers may also depend on the country's position in the trade network. So here the idea is that if you are located at the center of a complex web of relations among countries, well, then you're more likely to get in contact with new ideas, more than those who are at the periphery of this network. And because of this, you will show a better innovation performance. So what's the problem with these earlier works? Well, basically, the real issue here is that trade partnerships are essentially endogenous. And this endogeneity might represent a risk for drawing a real causal relationship between the formation of trade partnership and the increase of the innovation performance. And why is that? Well, consider this example. Suppose that a country adopts a new environmental regulation. And because of this regulation, we observe that the country improves its innovation performance, and at the same time, it redirects its national export flows. So if this is the case, what we observe is an actual correlation between trading partnerships and innovation performance. But this correlation is not causal, because actually the two phenomena are generated by a third phenomenon, that is the adoption of this new regulation. Okay, so because of this, we build on these earlier works, but we decided to explicitly deal with the endogeneity of trade networks. And in doing so, we are able to study the causal connection between them and the national creation of new technologies. In doing so, we make two contributions. The first one is that we are able to propose a simple model of national innovation production that formalizes the role of trade partnerships as a means to diffuse knowledge spillover across countries. And this gives us a way, and this model generates simple testable predictions. The second contribution is that we propose actually a new empirical strategy that allows us to test these model predictions. So what's this model about? Well, in our model, we posit that innovation performance in the green domain is determined by two factors. The first is the country's effort in terms of bottom-up and top-down actions, so consistent with the previous literature. The second factor is the innovation performance of its trade partners, so the spillover effects. And of course, the innovation performance of trade partners are determined by their domestic efforts and the innovation performance of their trade partners. So in a recursive fashion. So what is the intuition underlying this model? Well, the idea is that if agents from one country, country I, let's say, have cultivated an economic relation with agents in another country, then they might have acquired new knowledge that will be embedded in their innovation process and improve their innovation performance. This is basically what we refer to as learning by exporting. Interestingly, from a theoretical standpoint, in the unique Nash equilibrium, our model's equilibrium conditions can be expressed as a spatial autoregressive system of equations. And this gives us a way to structurally estimate the impact of both the country domestic efforts and the spillover effects on the performance in the green domain. We test our model using data from 19 EU countries, which are observed in the time span that goes from 1990 to 2015. And we measure each country's innovation performance by looking at the country's patent stock in residential energy efficiency technologies. And why we do that? Well, because these technologies are at the core of energy performance in buildings, which represent a key aspect in a sustainable transition pathway. No surprise that these improvements are the first point of the European energy strategy, because they have an impact on both the production and the consumption side. And how do we measure spillover effects? Well, we look at the position of the country in the trade network of energy efficiency household type appliances and equipment. This implies basically that we look at countries trading goods in a specific technological domain, and then we look at the degree to which these exchanges have an impact on the creation of patents falling in the same technological domain. And I will show you later on that we will deal with the endogeneity of this network measure by implementing a control function approach similar to that proposed by Ekman in 1979, but specifically designed for dealing with situation network related. Okay? So what's the prediction of our model? Our model posits that national innovation performance should be correlated with a specific measure of network centrality, to which we refer to as Katz-Bonasich centrality. And this is a very common measure of centrality that I will present you later on. And what do we find? Well, we find that this measure of connection has a positive and statistically significant effect on the national innovation performance of the country, both with and without applying the Ekman corrections, and even after controlling for other common drivers of innovation. Of course, this is not the whole story. We also use this model to investigate what is the new geography of innovation in Europe. Basically, once we estimate our model, we are able to calculate the Katz-Bonasich centrality of a country. And then we can observe whether countries with a specific value of Katz-Bonasich centralities are located close to one another in the European geographical space, or they are dispersed. And we find that countries benefiting the most from spillover effects, meaning those with a high centrality in the trade network, are not clustered in a specific European area. This means that innovation diffusion, at least now, follows a pattern different from that dictated by spatial constraints. Because what we observe is the emergence of a multi-center structure, where high centrality nodes are heterogeneously distributed in the geographical space and surrounded by low connected countries. In the final part of our work, we also use our model to test whether specific relations among pattern countries are able to magnify spillover effects. And we find 4 interesting things. The first is that spillover effects are larger when both countries' policy efforts are on track with the energy transition pattern. Moreover, we see that spillover effects are stronger when the partner countries are specialized in domain-specific innovation related to commercialization opportunities on the market. We also find that sharing a strong technological advantage in domain-specific enabling technologies enlarges the effect of this learning by exporting mechanism. And finally, we see that better opportunities for countries arise when they both share a high specialization in specific subdomain that allows them to exploit knowledge complementarity. All right, so this was a brief overview of our work. Now let's go into the details. Okay, I'll begin presenting our theoretical framework. As you probably all know, we can model the relationship among new ideas and innovation on the one hand, and the extant knowledge and expenditures in research and development on the other hand, using a knowledge production function. In the infant stages of this literature, the knowledge production function assumed a closed economy. And so we had that in this traditional approach, new ideas were a function of national extant knowledge and R&D. In a more recent development, we see the inclusion in the knowledge production function of the rest of the world. And so now we have that new ideas are a function of both national and international extant knowledge and R&Ds. The inclusion of the rest of the world is adopted in order to have a measure of the spillover effects. And in this, in the preliminary works adopting this approach, we have that this function was modeled as a linear model, where we had that spillover effects had an homogeneous impact on all countries. So you see in the equation of this slide that the innovation created in country I at time t is a function of the characteristics. So the external knowledge and R&D is produced by I at time t, and by those produced at by the rest of the world. So now, what's the problem with this formulation? Well, here we are basically positing that the innovation generated by a country also depends on the knowledge created by other countries. In other words, what we are saying is that countries are not independent anymore. And because it exists this dependence among countries, then we can explicit this cross-correlation among them by using an adjacency matrix. What this adjacency matrix is? Well, basically, this matrix is registering the extent to which countries are interacting with each other. Interaction which can be broadly defined. It could be that they are located close to one another, they have trade partnerships on, I don't know, and so on and so forth. So the generic cell ij of this matrix is actually registering whether there is an interaction or the intensity of this interaction. Building on this idea, we had that research from spatial econometrics provided a new knowledge production function that is expressed as a spatial autoregressive model. And so you now see in this second equation that the innovation created by countries at time t is a function of their characteristics and the innovation performance of the other countries to which they are connected through the adjacency matrix. So basically, the term phi is registering the spillover effects that are flowing across the connections registered by the adjacency matrix G. In our work, we built on this latter approach. And how we do this? Well, basically, we rearrange our spatial autoregressive model. So you now see that we have that the innovation of ideas is determined by the characteristics of the country, and this matrix that is denoted with I minus phi g raised to the power of -1. Well, the intuition of our work is that this matrix multiplied by a generic vector, say a vector of ones, for instance, this term here is proportional to the Katz-Bonasich centrality of agents in the network G, in the network represented by our adjacency matrix. So what is this Katz-Bonasich centrality? Well, if you want an intuition about this, we can use a Taylor expansion of this term here. And you'll see that basically what Katz-Bonasich centrality is doing, it is measuring the number of other agents, the number of other countries that a country can directly or indirectly reach, and penalizing through the discount factor phi the contribution of distant agents. In other words, this means that we are modeling spillover effects in a way where you have that closer countries have a stronger contribution to my innovation performance, while farer countries have less an impact on my innovation performance. All right, so basically, if we want to provide a new interpretation of this knowledge production function, what we have is that now a country's outcome is a function of its Katz-Bonasich centrality in the trade network, weighted by its own characteristics. That is to say that the innovation produced by a country is a weighted measure of its centrality in the export networks, with weights given by its own characteristics. Now, what's interesting about this reduced form of our equation is that we can prove that these are the model conditions of a unique Nash equilibrium of a knowledge production function with quadratic cost, where a country's effort is triggered by the effort of connected countries. Now that we have our theoretical framework, we can explicit how we use it, and we use it by investigating the export-led channel. So in our investigation, the term G, the adjacency matrix, represented the network. It is used to represent the international trade export networks, which mediates the flow of technological externalities across countries. So put differently, G measures an economic interaction effect. And this effect is learning by exporting. Now, as I anticipated to you, what is the issue when dealing with this model? Well, there might be an unobserved term that is correlated with both the generation of new knowledge in the country and the creation of trading partnerships registered by the network. If you recall my previous example, you can have, for instance, that the adoption of a new environmental regulation can boost innovation performance and redirect export flows. And when this is the case, identification is hindered by the endogeneity of the trade network. So in order to solve this issue, we use a two-step approach which builds on the idea by Ekman in 1979. So in our first stage of this procedure, that is the part where we control for the selection in trade partnership, what we do is to estimate something very similar to a gravity equation model. Okay, and so we model the probability that I and J will trade with each other by looking at the difference in characteristics between them. And then, of course, we add also country and time fixed effects. So what's interesting about this equation? Well, when we estimate it, what we are after is the residual term. Why is that? Because the residual term is the unobserved part of the relation between the two countries, is the part of their relations that we do not understand and we do not observe in the data. So in other words, is our measure of endogeneity, is our selection bias. So what we do under very standard assumptions is to sum all the residual terms related to one country. So that is to say, we are measuring the unobserved part of the relationships of country I with all other countries.
Valerio.
Yes.
I have just very quick questions. You mentioned that you estimate the gravity model based on similarity.
It is a sort of, so it is just to give you an idea. Okay, please.
Okay, but the model is based on which characteristics?
Yeah, okay, right.
So I mean, how do you characterize this similarity or diversity?
So we use the exact, so basically we take the characteristics of the countries used in the main model, okay? And we take the difference between I and J. So say, for example, one of the characteristics I'm using is, I don't know, energy tax rate in one country, okay? So we take the difference in the energy tax rate of the two countries, okay? And this is, of course, our exclusion restriction, because this value, which is the difference between the two characteristics, does not appear in the main model, okay? So basically, Zi and Zj is measuring the difference between Xi and Xj.
Yeah, no, okay. I got it. But, okay, let me ask later, okay?
Perfect, okay, thank you. So, as I was saying, we estimate this model, we register the unobserved part of the relationship stemming from I, and we plug this model into this value into our main model. Okay, so now we have that in our knowledge production function, we are including a selection correction term that is controlling for the unobserved part of the relationship of countries. And this allows us to sort out any endogeneity concern and thus make a claim of a causal interpretation of our results. Now, let's go to the data. Well, I'll go quickly on this part, but we can discuss this later on. So as I already anticipated to you, the dependent variable we use is the stock of the patents of a country in energy efficiency technologies, weighted by the population of the country, and we take the log of this. Then we use as our main controls one control for technology push that is proxied in our paper with the country's log R&D stock. And we have a control for the demand pool side. So basically we measure this with the average energy tax rate in the residential sector. Then later on, we will add also other controls. Basically, we will have a measure for the CAT's share of the country in specific patent domain, that is ICT and end-use technologies. We also measured if the country has a revealed technology advantage with these CATs. And then we measure the country's patent variety in the different energy efficient technology domains. And as I was telling you, this is a panel of 19 European countries that goes from 1990 to 2015. So let's go to the results. This is our main table. Okay, you see in our first column, we estimate a simple OLS, okay, where we have that our dependent variable is explained by the term registering technology push, country fixed effect, and year fixed effects. And as you see, we confirm extant literature that increasing technology push has a positive impact in the creation of patent energy efficiency. Now, what we do in the second column is to add our control for spillover effects. That is our term registering Katz-Bonasich centrality. And as you see, this has a positive and statistically significant effect. Well, even when in the third column, we include the selection control term, the unobservables, okay, the unobserved part of the relations among countries. Well, you see that this term is still positive and statistically significant. And regardless of the other controls that we add to our model specification, Network externalities are always positive and statistically significant. So this is our first finding. The second finding is related to the inclusion of the unobservable term. As you see, they have a statistically significant correlation with our dependent variable, meaning that neglecting this term in our model classification would result in a situation where you have an omitted variable, and this might hinder your identification. So it is crucial to include this term if you want to correctly estimate spillover effects. And the third result is that when we include a control for network externalities and the network correction term, where you see that our Akaike information criterion consistently improves, meaning that when we include these terms, we have a better understanding of the data generating process underlying patent energy efficiency. Okay, in other words, put differently, we better understand the drivers of our dependent variable. All right, so this is our main result. We can go now to the second part, that is, now that we have estimated the Katz-Bonasich centrality of countries, we can actually use this value to have further insights on the innovation diffusion process that we are analyzing. So here, for instance, what we do is to select the top 10 countries who have the highest Katz-Bonasich centrality in 2015. And we observe the evolution of their centrality across time, okay, over the 25 years that we observe in our panel. And we have already a number of interesting insights. So you see, for instance, that Germany has been consistently the country who has been most central to the trade network, the one with the highest Katz-Bonasich centrality, and thus it was the country who benefited the most from innovation spillovers in these 25 years. Then we have the other two important countries here, major players, are France and Great Britain. And we also see other interesting dynamics, like have a look to Poland, the one at the bottom of this plot. Okay, you see that Poland in the last 25 years rapidly reached other countries, and now it is benefiting from spillover effects in a way that it's similar to countries such as Belgium, Spain, or Ireland. Okay, but we can do more than this. So this is, for instance, the map of Katz-Bonasich centrality in two different time periods. You see that basically darker colors are associated to countries with a higher Katz-Bonasich centrality, and thus these are those benefiting the most from innovation spillover effects, while lighter color countries are those less connected and thus less benefiting from innovation spillover effects. Now, once we have mapped the value of Katz-Bonasich centrality, we can study if there is a spatial autocorrelation in these values. And we do this with a very standard and traditional metric, that is the Moran index, the global Moran index. And we look at the extent to which the global Moran index of the Katz-Bonasich centrality of countries have changed over the years. And interestingly, what you see is that whereas in the in the earlier years of our panel, there was some sort of positive spatial autocorrelation, meaning that countries highly connected were also clustered in space. They were close to each other. And so we had an area in Europe that was most benefiting from innovation spillover effects. On the contrary, in most recent years, this metric is going to zero, meaning that countries are more and more countries with a high Katz-Bonasich centrality are more and more dispersed in space. They are not anymore located in a specific area. And this implies that now innovation spillovers are benefiting countries in a way that is different from that dictated by spatial constraints. Countries are heterogeneously distributed in space, and countries who benefit the most are heterogeneously distributed in space. Okay, so this was our second finding. We now go to the third part of our investigation. And what we do is to test another hypothesis, that is, can we hypothesize that countries with given characteristics, by having a trade partnership between them, may benefit more from knowledge spillover effects with respect to other countries who do not share the same characteristics. So in order to test this idea that network spillovers are heterogeneous depending on the kind of relation that exists among countries, what we do is to modify our knowledge production function. And we do the following, basically. We say, okay, consider a specific characteristic of the country. Say our proxy for demand pool, okay? And now we say, okay, all countries who feature a level of demand pool that is higher than the median of Europe, then they are assigned to one group, group one. All the other countries, those who are below the European median, then they are assigned to a different group, group 0. And now we want to understand whether countries within the same group benefit from spillover effects that are different from those stemming from relations occurring between the two groups. Okay, so what we do basically is to split our adjacency matrix in two different adjacency matrices. The first one, G within, is registering relations within groups within countries belonging to the same group. While the second one is registering relations between countries belonging to two different groups. Accordingly, we have that the term theta within is capturing network spillover mediated by within group connections. And theta between is capturing network spillovers that are flowing among countries belonging to the other group. And so what we do is to use all the characteristics, all the controls used in our main table to create these different groups. Okay, but we do even more than this, because what we do is that we want to understand if belonging to a specific group, the one who holds a very high value in a characteristic, or the one who feature a very value in the characteristic, if one of the two groups is benefiting more than the other from spillover effects. So we further split our gene within matrix. And now we have two additional matrices. G within 0 is registering the relations between those who feature a very low value in the characteristic. And G within 1 is registering the relationships between those who feature a very high value in the characteristic. So now that we have in mind these two models, I can show you our estimates. And what you see here is that we now have the same regression model specification presented in our main tables, but we now split the effect of spillover effects by looking separately at the effects of spillovers generated by partners within the same groups and between the two groups. And then we further split the theta within effect by looking at the effect of those who do not share a characteristic or those who share a high value of that characteristic. And interestingly, what we find is that knowledge spillover effects are positive and statistically significant when we, well, let's say better. When we use as a characteristic technology push or demand pull, so we group the countries in the group of those who have a high technology push or a low technology push, or we group countries by looking at whether they have a high demand pool or a low demand pool, where we see that regardless of how they are grouped, they enjoy both spillover effects from within group connections and between group connections. But interestingly, when we further split within group effects, we see that the statistically significant effect comes from the spillover effects generated by those who show a policy effort equally committed to the sustainable energy transition, or those who both face a stringent regulatory setting. On the contrary, the others do not benefit from any statistically significant effect of spillovers. So this is our first result in terms of heterogeneity of network spillovers. The second, in the second slide, what you see is what happens when we group countries by using, by basically looking at those who have a high cat share or a low cat share, whether they have or not a cat RTA, or whether they have a high patent variety or a low patent variety. And here what you see that it is interesting is that when countries are more specialized in domain-specific innovation related to commercialization opportunities on the market, so they have a low cat share, those are those who benefit more from spillover effects with respect to those who do not have the same characteristic. However, if we look at cat RTA, the situation is different. Those who do not have a revealed technology advantage in cats feature spillover effects that are lower with respect to those who both share a revealed technology advantage. And finally, if we look at patent variety, we see that those who have a low variety, meaning a patent concentration, meaning those who are highly specialized in specific domains, those are the countries that when trading with each other benefit from higher spillover effects with respect to those who do not feature these characteristics. So, in conclusion, what we find in our paper is that maintaining a central position in the network of domain-specific effort, it is fundamental, it is paramount to magnifying the effort exerted by a country in fostering its innovation performance. This is not just it, because we also find that spillover effects, these spillover effects received by being central in this network, are stronger if the country is partner with another country and they are both specialized in domain-specific innovation, or if they share a strong technological advantage in domain-specific enabling technologies. And moreover, they have better opportunities as partners if they are both highly specialized in specific subdomain, so that they can exploit knowledge complementarity. And taken together all these findings, they suggest that a higher policy coordination among these countries would be essential if they want to accelerate and improve knowledge complementarity exploitation. So this is it. This is my presentation. I hope you enjoyed it. And I mean, I'm open for discussion.
Okay, Valerio, thank you very much. We really enjoyed your presentation, and we are now ready for questions. So I will give priority to our PhD students, if any. So please, if you have questions, go ahead.
By the way, may I add something for PhD students here? I know that some of you followed the class by Elena Paglialunga. So you already know that all the models presented here can be actually replicated in R with a package that is called Econet. So, I mean, if you're interested in dealing with this kind of work, you have all the means to do that. And I'm available to help you since I'm the creator and maintainer of the package. Okay, so please go ahead.
Okay, thanks, Valerio, for this clarification. And if there are questions from the PhD audience. Yes, sure, Francesco, go ahead.
Okay, thanks, Valerio, for this interesting contribution. I follow a lecture with Elena, so I previously know your work. And I have a question. Why the Katz-Bonach centrality and not the eigenvector, for instance? Because Katz centrality is based on geodesic distance, is measured following the geodesic distance in a certain sense. The results should be not, could be not affected in a deeper way, so both are really similar, but why not eigenvector? Thanks.
Okay, should I take more questions, or how do you usually do, Alessandro?
Sorry, Valerio?
Should I take more questions, or
no, you can answer directly.
Okay.
I think
okay.
we have time to answer one by one.
Okay, so well, thank you, Francesco. This is actually an interesting question. So there are different reasons why you prefer Katz-Bonach centrality to eigenvector centrality, but I will focus mainly on one. So Katz-Bonach and eigenvector centrality are two strongly related measures. Okay, what it's really different here is the discount factor. Okay, because eigenvector centrality, what it's doing in a way is to assign the same discount factor to all countries, regardless of their distance from the country. Okay. And this implies that basically you are exogenously assigning a measure of spillover effects. Okay, so this is predetermined by you before running estimates. Okay. On the contrary, if you use Katz-Bonasich centrality, what happens is that the discount factor is endogenously determined by your data. Okay, so the spillover effects will change every time you change your data, and it will be determined by the process you are analyzing. Okay, so from a purely, let's say, statistical standpoint, you want that because you'll have more stronger results, more robust, because you are computing spillover effects endogenously in your model. But of course, there's more than that. And the point is that Katz-Bonasich centrality is actually easy to model in a model framework. Okay, so it is easy to show that in a Nash equilibrium, agents behave according to this Katz-Bonasich centrality. Okay, so there are both theoretical reason and statistical reason. Now, of course, you could try to replace Katz-Bonasich centrality with other measures. And sometimes it might be the case that these measures perform better than this. Okay, this depends from the data, of course. But the point here is that, do you also have a theoretical interpretation for that? If yes, then I invite you to explore this venue of research. Otherwise, I mean, you would lack of a theory that justify your results. Okay, perfect, thank you.
Okay, thanks, Valerio.
Thanks, Valerio. Do we have other questions? Let me say that if you have questions, please raise your hand. Okay. Okay, maybe I can also do my part. So Valerio, I have a couple of questions. Maybe meanwhile, other students think about their questions. I can start asking some issues.
Don't be so
first
mean,
of all,
Alessandro. I know you can, so just kidding. Go ahead.
No, first of all, seriously, it's a great work. There's a lot of work inside, a lot of data. So congratulations. And the points are maybe 2 points. The first is that, as you know, there are many ways through which a country can be exposed to new ideas from abroad. No, and this is one of the main issues faced in the paper. And you model this exposure through trade, and which is basically embodied technical change, which is fine. But this way somehow rules out many important intangible channels, such as collaborations in R&D processes, academic exchange, and so on. So I would just mention this issue in the limitations of the paper, given that there is a large literature that looks at the same topic from a different perspective. This is just as a comment. And then the main point is about the learning by exporting mechanism, which I like a lot. I mean, it's a nice topic, but learning by exporting means basically productivity gains deriving from basically when you enter new export markets. No? So my point is that given that you use country data at country level, I'm a bit concerned that it's not fully allow you to observe the mechanisms through which learning by exporting works. That is to observe if a specific group of firms actually learn from export opportunities and more export penetration. In this case, I would just downsize this issue of the underlying mechanism of the learning by exporting. Considering that, I mean, I like a lot this explanation, but I have some concern just regarding the use of aggregate data, given that all the literature about learning by exporting, is based on microdata that looks specifically follow firms over time and through across markets. And that's it, Valerio.
Yeah, no, thank you. I mean, honestly, we share the same concern about this, in the sense that, of course, by aggregating data, you risk to miss some crucial information, okay? Though at the same time, we try to deal with this by really narrowing the technological domain of the goods that are exported. Okay, so in a way, we try to deal with this by saying, okay, we don't look at general innovation of every patents by looking at all the goods traded between groups. Okay, but what we try to do is to at least tackle part of the issue by saying, okay, we look just at the goods traded in the domains related to the patents that we are studying. Okay, of course, one could do also better in by looking at micro relations, or in the other case you were suggesting, by looking also at other forms of relationships, okay, like co-creation of knowledge, co-patenting, for instance. Okay, I mean, there might be concerns. It is also true that we do have an endogeneity correction, okay, for what we do not observe in our data, for what concerns relations among countries. So our at least hypothesis is that by looking at a very specific technological domain, and by including a network endogeneity concern, most of these issues should be in a way controlled for. Okay. Now, I hope you're not my next referee and that someone else will buy the story.
No, why not? I just suggested to mention as a
no, absolutely,
which
absolutely.
Is, I mean,
no, but I agree with you. That is why we tried so hard to select appropriate data, because we shared, we as a co-authors, we shared your concern.
Okay, that's mean that I understood the paper very well. Okay, great. Thank you,
I see
Valerio.
there's a raised hand.
Yes, sure, from Andrea Scani. Andrea, if you're there, please go ahead.
Yes, I am. Thank you, Alessandro. Thank you, Valerio. I really like the presentation and I do buy the story. And I had a similar comment to what Alessandro just mentioned, but more maybe conceptual rather than data-based. And my connection was also on and off, so I might have missed something. So forgive me if I'm saying something that you already addressed. So the first thing is about the trade channel, and specifically the exporting channel. I was just wondering, very basic question, why you picked exports and, for instance, not imports, or rather foreign direct investment. FDI in particular is a way more tangible way of transferring knowledge, technology, workers like engineers, or even managers that manage the innovation process. And specifically, my concern with exporting is that I'm not up to date with the literature on international trade, but what I remember from it is that the best performing and most innovative firms self-select into exporting. So they might be actually more innovative before exporting. And some papers, in fact, downsize the role of learning by exporting. And more than that, I remember that there is a learning by importing mechanism, if anything, because they can reverse engineer intermediate products or final products. So I was just wondering whether you're thinking of extending your analysis to these other internet cross-border channels. What's your thought about that? Thanks.
Well, thank
Valerio,
you.
just before we start answering, let me add just another little piece of questions related, closely related to the one by Andrea. Also consider that there's a substitution effect in the firm, because maybe a firm can choose to make new innovation in-house, okay? But a firm can also choose to import new innovative products and change the input mix through increase that imports.
Well, thank you very much. Well, I have a few things to say about this, in the sense that our main inspiration was this work by Ho and colleagues in 2018, which is basically about import networks. Okay, and we do validate in a robustness check their theory, and we show that also import matter in the creation of, in improving national innovation performance. But then again, this is not the story we're selling in our paper, and we were most interested in looking at the export by learning mechanism. Then, of course, you might have concerns that there are some persistent effects, like, for instance, or some self-selection effect. So very innovative countries are also those who export the most, and so you have a mechanical correlation between these two terms. So this is why in another robustness check, I'm sorry I don't have it here to present it, but we include some lags in our regression specification, and we show that, of course, the effect of the spillover, the magnitude of the effect of the spillover decreases, but still remains positive and statistically significant, telling us that yes, for sure, past performances predicts part of my actual performance and may have something to deal with my network connections. But at the same time, because of our endogeneity correction strategy, when we include this lag in our specification, we automatically include it also in our correction procedure. So we are now correcting also for the fact that that country has been very innovative in the past. So, and when we do that, we deal with the concern that Andrea was suggesting. And since, despite the inclusion of all these terms, both in the main and in the first stage of our model, then we can claim that, of course, being very innovative has an effect on future performances and might have an effect in selecting your position in the centrality of the network. But even when I control for that, network spillovers are still significant. Okay. And well, for future venues of research, it is interesting that you're mentioning this, because our next work will be exactly on co-patenting. Okay, so we're trying to understand what is the role of that network in on other innovation performances of countries. So thank you for giving me the opportunity to at least mention it.
Thank you.
Thank you, Valerio. Are there other questions from the audience? Not so far. No question from YouTube. Okay, so
perfect.
Actually, okay, so goes through the issue, okay, with a very fine tooth comb, okay, given that I'm not your referee. No, but I mean, this
but
is
I
just
see I raised them now, Alessandro.
No, just because this is a good chance to discuss.
Yeah.
But let me give priority to Francesca, who has a question. So Francesca, please.
Hi, can you hear me?
Yep.
Yes, we can.
So it was extremely interesting. Thank you, Valerio, for the presentation. I was just wondering if you do account somehow for the bilateral relationship of some of these countries, which sometimes are still affected by spatial distance. So is there a way to account for that?
So since I cannot hear you very well, just to clarify your question, are you asking whether I can control for the effect of distance on the probability of partnerships? Or you're saying that I should control for that in my main model?
Yeah, there are also, I mean, what I'm talking about are like bilateral trade agreements that still exist even afterwards being within the European Union. Mm-hmm. And sometimes these are also affected by space, you know, by this spatial distance.
Right. Well, of course, I mean, this work is interested in network dynamics rather than spatial one. Okay, though we do present some implication in terms of economic geography, right? However, let me say that when we implement our Heckman correction approach in 2 steps, in the first step, we do include country fixed effects, meaning that basically we are controlling for a number of time invariant characteristics, which may explain the reason why 2 countries are trading with each other. And this surely includes all spatial related variables, all right? So not just whether they, I mean, their distance, but also whether they have a border in common or they have a specific infrastructure connecting them, as long as this is persistent in time. So yeah, actually we thought about that. This was also a concern recently raised by one of our referees, and so it is appropriate to your question, and but we do have a control for it, so we should be safe on at least on this side. Okay, thank you.
Thank you, Francesca. Let me check if anyone from the audience has a question. No. So Valerio, I was speaking about the endogeneity, the main endogeneity issue you face in the paper, that is the relationship between innovative activity and set selection into export markets. I take the instrument, but maybe you should also consider, maybe for additional checks, that in some cases, the policy itself might be somehow endogenous to the trade pattern. I mean, you know that energy economic players are sometimes huge. Okay, they have a lot of economic power. And, I mean, there are lobbies. There is literature on this topic. There's a paper by Bona and Nicoli, and maybe another couple of papers that if you want, I can send you. And this literature stressed specifically this issue, okay? That there's lobbies are able to affect the direction of this policy. So I don't know if there's a way to control for this degree of lobby in the energy market or specific trade markets that might somehow affect, or on the other hand, that you can use an external source of variation, maybe a new policy or heterogeneity of policies across countries or sectors that you can exploit to further corroborate your estimates.
Well, it's interesting you're mentioning this, but this of course goes a little beyond the scope of the work, but this is exactly the question that we raised at the end of this work. Okay, and when I was mentioning our next work about co-patenting, okay, this is exactly the idea that it is the reason why we adopt a new policy, we begin a new collaboration, a new knowledge co-creation. There is a number of actors involved, whether these are investors, lobbyists, and so on and so forth. So in this very preliminary work, what we are doing is to include measures about the government of the country. So not on the policy side, but on the political side. Okay, so we do observe the governments that were formed in the last 30 years. We observe their manifestos. Okay, so actually what they proposed at the beginning, when they were elected. Okay, and we try to see the extent to which changes in governments may affect the reaction of investors and lobbyists and so on and so forth in determining the innovation performance of a country, while controlling for the fact that these governments are also affecting how knowledge co-creation is made across countries. Okay, so this is exactly the direction that we are following in our next work. So we're perfectly on track.
Okay. Mm-hmm. Okay.
Maybe maybe next year you may want to invite me to present the next work.
Oh, that's for sure. Why not?
Perfect.
Okay, Valerio, I think we have no additional questions. Let me just make a final check. No. So we thank you very much for presenting this interesting paper. And of course, we would like to invite you in the next webinar series next year. Meanwhile, I wish you a very relaxing and safe vacation. So to you and also to your co-authors, Valeria and Elena, who are a friend of mine also. So thanks once again, and see you in the next year.
Okay. Thank you very much, everybody. I really enjoyed this, and thank you for this kind invitation. It was nice presenting here. So thank you again.
Yes, I would like also to thank all the organizers and all the attendees for this great webinar series. Okay, thank you very much, and bye-bye.
Bye. Bye-bye.
Bye-bye.
Ciao a tutti.
Bye.
Ciao a tutti.